Hi, I'm Riaz Ahmed, and in this video, I will discuss regression analysis. As shown in the displayed diagram, there are three main types of machine learning. Regression analysis is a type of supervised learning. Let's begin by first understanding machine learning and supervised learning before discussing regression analysis. Machine learning is the process of training a piece of software called a model to make useful predictions. Why do we need machine learning? Machine learning offers a new way to solve problems, answer complex questions, and create new content. Machine learning can predict the weather, estimate travel times, recommend songs, autocomplete sentences, summarize articles, and generate never seen before images. And supervised learning refers to the process of building a machine learning model that is based on labeled training data, where the label is the known correct answer. Each row of a dataset consists of input variables and a desired target variable. These machine learning systems are supervised in the sense that the machine learning system training data has the known correct results. In this diagram, you can see a dataset of housing prices. It consists of input variables or features and a target variable or label, which is housing price. It is an example of labeled data. Two of the most common types of supervised learning are linear regression and logistic regression. Now let's dive deeper into regression analysis. Regression analysis is the process of estimating the relationship between input and output variables. A regression model predicts a continuous numerical value. For example, a weather model that predicts the amount of rain in inches or millimeters is a regression model. In regression analysis, it is assumed that the output variables depend on the input variables. So we want to see how they are related. Consequently, the input variables are called independent variables and output variables are called dependent variables. Regression analysis helps us in understanding how the value of the output variable changes when we vary some input variables while keeping other input variables fixed. In linear regression, we assume that the relationship between input and output is linear. This table displays some examples of regression models such as future house prices, future ride time, cricket chirps per minute. Now let's have a look at a regression model example in a bit more detail. It has long been known that crickets, which is an insect species, chirp more frequently on hotter days than on cooler days. For decades, professionals and scientists have categorized data on chirps per minute and temperature. Using this data, we can explore this relationship. So let's examine data by plotting it. As expected, the plot shows the temperature rising with the number of chirps. Is this relationship between chirps and temperature linear? Yes, we could draw a single straight line like the following, as shown in the diagram, to approximate this relationship. The line does not pass through every dot, that's true, but the line does clearly show the relationship between chirps and temperature. Using the equation for a line, we could write down this relationship. In this diagram, equation for a line describes the relationship between the number of chirps per minute and temperature in Celsius. Finally, there is a quick overview of regression analysis key components. Key components of regression analysis include independent variables or features. These are the variables that are used to make predictions about the dependent variable. There can be one or multiple independent variables. Dependent variable or target This is the variable that we want to predict or explain. It is usually a continuous numerical value. Training data. Regression models are trained on a dataset that contains historical or known values of the dependent and independent variables. The model learns the relationship between the variables from this data. Regression model. It is a statistical model that represents the relationship between the dependent and independent variables. The model discovers these patterns through training using training data. Model evaluation. Various metrics are used to evaluate the performance of the regression model. Common evaluation metrics include mean squared error, mean absolute error, and R squared, also known as coefficient of determination, etc. Prediction. Once the model is trained, it can be used to make predictions for new or unseen data. Given the values of the independent variables, the model predicts the value of the dependent variable. Applications. Regression analysis in machine learning has a wide range of use cases across various domains, such as predicting stock prices, sales forecasting, real estate price prediction, healthcare outcome prediction, etc.